So in the IEEE community, 802 project group has been formed, and they are responsible for developing a standard for local area network and metropolitan area network, that is LAN and MAN. The protocol and standard developed by IEEE 802 deal with the physical and the data link layer of the open system interconnection model, that is OSI model. The OSI model defines 7 logical layers of a networking framework and was developed by International Organization of Standardization. So it is developed by ISO, and the model name is OSI. And we know that it is of 7 layers and it is having 7 logical layers, right? So, but this particular protocol is a reference model, and it is not an implementable model. Implementable model is a TCP/IP model, which is of 5-layer model. Now, it is showing, it is telling the history of 802 this IEEE 802 project, how it came into the picture. So when this OSI model has been introduced at that particular time, this project 802 has been formed by IEEE. So IEEE 802 divides the data link layer into sub layers, which is link layer, control, and MAC layer, as I told you. So the second layer, which is the data link layer, is divided into logical link control and MAC layer. Now 802 is responsible for many widely used standards such as Ethernet 802.3, wireless LAN 802.11. IEEE 802.15.4 is standard similar to 802.11. As I told you, this 802.11 is wireless LAN, which is giving the local area network connectivity in a wireless manner for non-constrained devices. But for the constrained devices like low power devices like IoT devices, 802.15.4 is very much used in the wireless media. Okay. While 802.11 define a standard for wireless LAN, 802.15.4 is responsible for. It is also for this is also for the wireless, but it is for the low rate wireless personal area network. Okay, so this is the network that we are talking about, which is having the low rate, and W is for the wireless, of course, and PAN is for the personal area network. So it is for that, but almost the working principle is almost the same for 802.11 and 802.15.4, but there is slight difference between the protocol, because here we are not using the heavyweight protocol. Instead, we are using some lightweight protocol, which may be suitable for the a low rate or low power IoT devices. This 802.15.4 supports 2 classes of devices. So there are two type of devices exist in 802.15.4 protocol, which is fully functional device, that is also called FFD, which has full network functionality, and reduced functional device, that is called RFD, which possesses limited functionality. Okay. All personal area network, that is PAN, consists of at least one FFD, which act as a PAN coordinator, which is responsible for maintaining the PAN. So as we all have all 5 component in mind of IoT, that is starting from the thing or the devices where we are talking about wireless sensor network. Then we have the gateway node, which is actually connected with the internet, and it will collect the data from the wireless sensor nodes, and it will send the data to the next component, which is called cloud. Cloud will do the storage and the processing of the data, and the processing will be done using some analytical algorithms. And after that, the result will be sent to the user through through the user interfaces like mobile application, maybe the messages, or maybe the web application. So the second component, which is the gateway node. So gateway node is actually connected with the internet, and there are the low power devices. So you consider that fully functional devices here we are talking about as a gateway node, and reduced functional devices are we are talking about the sensor nodes. So there it says that all personal area network consists of at least one FFD. It says that at least one gateway node should be there, which act as a PAN coordinator, which is responsible for maintaining the PAN, and it is for maintaining the personal area network. Reduced functional devices are responsible for directly obtaining data from the environment and sending them to the PAN coordinator, right? So I think you understood that the reduced functional device here is the sensor nodes, which are responsible for generating and responsible for generating the data and sending the data to the gateway node. And this gateway node is nothing but the full functional device that are also called PAN coordinator, that is personal area network coordinator. No, there are different figure which shows various topology which PAN can adopt. In figure, the red devices are PAN coordinator, the yellow devices are fully functional devices but are not PAN coordinator, and the green devices are reduced functional devices. So there are three categories. One is the PAN coordinator, which is the fully functional device, and we select it as a PAN coordinator. There are fully functional devices also, and there are the reduced functional devices. So fully functional devices is in the form of maybe yellow or the red. One of the fully functional devices is called PAN coordinator, which is using the color red, and the reduced functional devices which are in the form of green. As seen from the figure in the star topology, all devices directly interact with only the PAN. So this is the star topology. In this, you can see the full functional device as well as reduced functional device are sending their data to the PAN coordinator. Now, if you see the peer-to-peer network, where one node can communicate with another node, in that way, we have one PAN coordinator, and we have some full functional device, some reduced functional device, and they are sending their data to the either full functional device or the PAN coordinator. So these and this device can send directly to the PAN coordinator. This and this device will send the data through this particular reduced functional device to the PAN coordinator, and this particular reduced functional device will send their data to the full functional device. Okay, then this is the tree cluster topology, in which we have you can see here, this one is head of the cluster. So this is one cluster, this is another cluster, this is another cluster. Here you can see this is the head of the cluster. So this node will collect the data from this node and this node and send it to the PAN coordinator. This node will collect the data from this and this node and send it to the PAN coordinator. And this node will collect the data from this and this node and will send it to the PAN coordinator. So this is the way how the communication will take place, and it is supporting different type of topology, because when we place the sensor node in the network, it is ad hoc structure. Okay, and after the deployment only we will come to know that which type of structure it is forming. So it is based on the network connectivity, based on the neighbor of a sensor node. The sensor node will create the topology based on their connectivity. Now, as we have discussed, like 802.15.4 is almost the same as 802.11, and 802.11 work on TCP/IP protocol. Now, if we consider the TCP/IP protocol, where we have 5 layers, here 802.15.4 is responsible for only 2 layers, that is physical layer and the MAC layer, which is not responsible for link layer control, which is the part of data link layer. So in the data link layer, we have two parts, which is link layer control and MAC layer. So 802.15.4 is only responsible for manipulating the physical layer and the MAC layer. Okay, MAC layer of the data link layer. Now let's talk about the physical layer of 802.15.4 and how it is working. The original IEEE 802.15.4 standard release on 2003 adopted a wideband physical layer using direct sequence spread spectrum. So this is the communication technique that is used, that is direct sequence spread spectrum technique. It provides physical layer operation in 3 frequency band: 868 megahertz band available in Europe, 915 megahertz band which is available in US, and 2.4 gigahertz ISM band which is unlicensed band available worldwide. So what we are using in India is 2.4 gigahertz ISM band. So what is that band is? That is called ISM. I standard for the institution, then S for the scientific, and M for the medical. So for those purposes, there are some band which is unlicensed band. So that is free. So that actually band we use for the IoT devices. Okay. 27 channels were supported across these three bands. We have different bands, right? So we have band of 868 megahertz, which is used in Europe, 915 megahertz, which is used in US, and 214 gigahertz, which is used in different countries, including India. Twenty-seven channels were supported across these three band. 868 megahertz support one channel, 915 megahertz band support 10 channels, and 2.4 gigahertz support 16 channel. So 2.4 gigahertz uses 16 channel communication. And in that way, we can communicate 16 data packets individually without any collision, right? The three band provide a transmission rate of, so for this, the transmission rate is 20 kilobyte per second. For 915 megahertz, it is 40 kilobyte per second. And for 2.4 gigahertz, it is 250 kilobyte per second respectively. In the later revision that follows in 2006, 7, 9, may additional band was added in 802.15.4 because it was introduced in 3, 6, 7, and 9. Some improvement has been done and many other bands has been added. So in the physical layer of 802.15.4 is responsible for the following two level function. So there are different functionality that has been supported here. One is the data transfer. So definitely physical layer is responsible for transmitting the data as well as reception of the data by using different type of antennas. So it may use transceiver, transmitter and receiver antenna, which will be like, it will receive the data and it will transmit the data. Then it will also responsible for energy detection of current channel. So in the current channel, if it is detecting any energy, means some communication is going on. The link quality indication, it will talk about that when we receive any data, then what is the link, what is the reception quality of that particular signal. Then we have clear channel assessment, which we use generally in you might have you might have seen like CSMA-CA and CSMA-CD, that is collision detection and collision avoidance. Okay, carrier sense multiple access. So by sensing the carrier, it will find out like, is there any communication going on or not. If it is not going on, then the protocol will decide to send the packet or not, right? Otherwise, there will be the chance of collision, and if we are colliding or the data will be collided, so it is a waste of energy. So clear channel assessment functionality has been used in 802.15.4 physical layer. The energy direction of receiver is used by the upper layer of their channel selection. So this energy detection, whatever energy it is detecting, it will be used by the upper channel, upper layers. Link quality indication, that is LQI, indicate the strength of received signal. So if we are receiving the signal from one node, so based on this link quality indication, or it is also called RSSI, receive signal strength index. By that, we came to know that what is the signal strength in the decibel, millidecibel. We calculate the signal strength, okay? Wireless signal strength. The clear channel assessment is done based on the following three methods. So we can, in this particular functionality, we have different method like energy detection, carrier sensing, combination of carrier sensing and energy detection, right? So both we can use, or either of these we can use for clear channel assessment functionality, okay, which is energy detection and carrier sensing. So carrier sensing, as I told you, CSMS-CA, that is for the collision avoidance, and CD is for the collision detection. So in the collision detection, we first detect the collision, and then we see that whether we have to send the data or not. In CA, that is collision avoidance, we detect it, and then we use different type of packet first, not the data packet to send. We'll send some RTS and CTS packet, and then we finally come to know that there will be no data transmission in future, so we'll send the data, right? But here we doesn't waste much of the control packets, because it is a low power network. So we use carrier sense, we detect, and if there is no communication going on, we'll send it. And the same thing will happen to the energy detection. Energy detection means if we are getting any energy means we are getting some signal strength. It means that some communication is going on. So all these are the functionality related to the physical layer of 802.15.4. Now let's see the physical layer packet structure, that how the packet prepared by physical layer look like. The packet contain a synchronization header, which is the combination of preamble. Then we have the delimiter to indicate the start of an arrival packet. Okay. Then we have, it also consists of header, is the header. It indicates the length of the payload followed by the payload, actual payload. The preamble is used to get the symbol and chip timing, and occasionally uh, for coarse frequency adjustment. Now, why we use preamble? See, preamble is of 4 byte. So what happened here is, before sending actual data, we use some preamble bytes. Now let's understand the preamble first, then we'll go to the delimiter, then header, and then the actual payload. The preamble is just like, let's say before starting the class, I'll not start the class like while entering into the class, I'll not start the topic. Now, before that, what I'll do is I'll talk about the topic, or I'll talk about the previous topic, right? Then only I'll start the actual topic. So why I'll do that? Because so the student who have just taken the class will be in the mood of that particular class, or maybe not in the mood of learning. So what we do is we just create the awareness that this is the thing that we are going to talk. So that is not actual lecture, right? So before that, we are doing some preamble type of thing, some sort of preface we are putting into the class, so that the student will be attentive and ready for taking the actual data or actual class. So just like that, preamble is used. So preamble is nothing but the 4-byte bogus information that will send to the device. So maybe that device is not listening, or maybe the device is not ready to receive. So preamble signal will just wake that particular device up so that it will be ready to receive. Okay, so preamble is used for that, so that the actual data will not going to be wasted, and the preamble signal will tell the receiver node to be ready to receive the data. So that's why we use preamble. Then we have delimiter. It indicates the arrival of the actual data packet. So this 1 byte is some sort of, let's say, all 0 or all 1, which indicate, or when we receive all 0 at once, 8 bit. So we understand that after that actual data will start. Okay. Then we have the actual data which talk about the header size. Okay. So this header size is the header is telling you that what is the length of that particular packet, and that will be there in the header. So only 7 bits of header is used for specifying the length, which gives the maximum length of 127 bytes for the Mac frame. So you see the actual payload is of maximum 127 bytes, not more than that. Okay. Typical packet size for home application are generally about 30 to 60 byte, whereas interactive application required packet of larger size. See, when we do home smart home applications, so in that whatever data will be flown in between the user or in between the appliances are maximum 20 to 30 byte, not more than that. And we are talking about 127 bytes. Okay, so it can accommodate, no problem, but it should be in that particular range, not more than that. So we are talking about very less information that has been passed between two nodes, or one node or the gateway node. So this is about the physical layer packet. Then we will talk about MAC layer. We have different functionality related to MAC layer, that is association, disassociation, acknowledged frame delivery, channel access mechanism, frame validation, guaranteed time slot management, and beacon management. Okay. Association and disassociation means, um, see, while communicating the data with one node, we used to make the adjustment, and that adjustment is called association and disassociation. So before actually taking the data, or before actually sending the data, first we'll make the connection between the devices, and then only we send the data. That is the functionality which is coming under MAC layer, association and disassociation. Then we have the acknowledged frame delivery. This is the feature that we'll use. So after the delivery, after receiving a particular packet, we'll send the uh, acknowledgement, okay, that we have received the data. Then we have channel access mechanism, which is, so we are using the wireless channel, right? So for using that particular channel, what are the mechanisms that we have used, right? So either we have used the TDMA, CDMA, like different type of protocols are there. So which protocol we have used, that we can use in MAC layer. Then we have frame validation, whatever frame we have received, that we can validate. Guaranteed time slot mechanism, it is used in the TDMA protocol, where there is a time division multiple access, where we provide the particular time to the particular device to send the data and to receive the data. Then we have beacon management. It is managing the connectivity between the nodes so that the link will be maintained. So if somebody is not sending the data, they are sending the beacons. Beacons are nothing but some small signals which will be sent so that the other node can get to know that one node is alive or one node is working. So all these are the features related to MAC layer. Now let's talk about the frame, the MAC format, the packet format or the frame format of the MAC layer. So the frame control is the first field in the frame. So we have the frame in the MAC layer, which is first one is the frame control, which is of 2 byte. So what is a frame control? Is the first field of the frame, which basically tells about the type of frame being transmitted. So which type of frame is being transmitted, we can represent with the 2 byte address format, and also handle acknowledgement. So used to transmit type of frame being transmitted. Then we have address format, also handle acknowledgement. There are 4 type of MAC frames. Data frame, so the frame may be the data frame may be the MAC command frame, or frame may be the acknowledgement frame, or frame may be the beacon frame. So these are the 4 type of frame that will be used. To represent that, we'll use 2 bytes. Then we have the sequence number field is used to match the acknowledgement frames. So this sequence number is the actually the frame number, and it is for matching the frame acknowledgement. So when we receive the acknowledgement, we'll match it with this particular sequence number of that particular frame that has been received or not. The size of the address field varies between 0 to 20 bytes. So we have the source address and we have the destination address. It might contain the short address of 8-bit. So we'll give the ID, or we'll provide the IEEE address, device address, which is of 64 byte, bit, or we have the standard, you know that in the physical address we have 48-bit, right? So we can use that. So it may vary from 0 to 20 bytes. The payload field is a variable of size, because here we are having the actual data. But the size of the whole MAC should be less than 128 bytes. So we know that what is the total payload value, it should be less than 128 byte. We have seen in the physical layer, right? Considering the size constraint of the physical layer payload, the frame check sequence. So this is for the checksum CRC, that is cyclic redundancy check, will use here, so that we can verify the integrity of the frame, whether the frame that we are sending, it is the same or not. Just like your hashing technique that we'll use in cryptography, where we put the hash along with the actual message to find out the integrity, or to check the integrity of the message. The same way we'll use the frame check sequence, which is nothing but a 60 byte cyclic redundancy check that will send. So this is about the MAC layer of IEEE 802.15.